So how do you select the right design? Well, it's a combination of both art and science. The science is all the stuff we're going to hit in the first couple of lessons. We're going to show you ways to mathematically quantify the different impact of the choices you might make. And these are all being made to find that optimal trade-off between costs and service, as well as between different types of costs. And using these models, you'll be able to select the best approach given the characteristics of the product, the supplier, the customers, the markets, and any other thing that might have a factor. But it's also an art because the future's uncertain. We don't know where things are going to go. And this is especially true if I'm making decisions about large investments over a long period of time, such as facilities or large pieces of equipment. These assumptions that we make that feed into the models rarely hold true completely. They're never going to be perfect. They're assumptions. The data are never going to be completely accurate, regardless of the precision that you go to. So simply having 13 decimal places doesn't make a piece of data any more accurate. It might make it more precise, but it might actually make it overly precise for the level of accuracy that you have. So it could give a false sense of security. And we'll talk more about this. And finally, situations change over time, sometimes abruptly. So there'll always be an essence of art to this. It's not a pure mathematical program. We're going to spend a lot of time on developing these math programs, but they're used to feed in and help support the decision. So let's look at some classic ways of doing this. This is from a paper by Marshall Fisher, classic in the field, that looks at how you should select the right supply chain for the product. And what Fisher did, he said, if you look at it, there's really two types of products that serve two types of markets. There are functional products, and these are things like soup, like the example that I have here, where it's predictable demand, long life cycle, the margins are okay, not that much variety, there's not that much of stock out, and you have a fairly long lead time. And for these products, you want to drive down costs. You want to make them as efficient as possible. But then you've got these other products, and he called them innovative products. And for these ones, the demand is unpredictable. It's a short life cycle. Things happen quickly. Margins are much higher, right? You have higher variety. Because they're innovative, you don't know exactly what the market's going to be yet. That's why you have such high variety. There's errors at production because it's new products. It hasn't been fixed totally yet. High stock out rates. And for these products, you want to match supply and demand. Two different types of supply chains to support two different types of products going to two different types of markets. So why do we care about this? Well, this changes the way that we approach our supply chain design and how we perform our supply chain functions. So for demand forecasting for these functional products, I have history. So I'm going to use exponential smoothing, time series. I'm going to have detailed analysis of trends, seasonality, maybe geographic factors, because I have history I can lean on. For innovative products, not so much. I'll have to use more qualitative methods, like looks-like analysis. So I'll find a product that was launched, say, last year that's kind of similar and use that as a proxy. I might use the Bass diffusion model. So it's a very different types of forecasting. For inventory management, I'm going to be probably periodic review because I want to make this, I'm not going to spend a lot of time on it, so I want to minimize that time. I might build up inventory for peaks. For soup, I probably have a bigger peak in the winter, so I'll pre-build because I know it's probably not going to go out of style. It's not as perishable. Very different over here in innovative products. These are more like the news vendor problem, single period. I've got to push my product first because if I miss that first wave, I might miss the whole market. Very different ways of managing inventory. Transportation. For over here in functional, it's full truckload, it's ocean. Cost dominates speed. I'll go for a slower mode if it lowers my cost. I might require minimum order quantities to DCs to get that economies of scale. Over here in the innovative products, not so much, just the opposite. Speed dominates cost. I don't want things sitting in a boat. It might miss my whole market. My market window is very small in these types of products. So speed dominates cost. However, this is just a 2x2 matrix, right? You have two types of products and two types of supply chains. The real world's more complex. These are not hard and fast rules. These are more directional. So not all products will be purely functional or purely innovative, but this gives a nice sense that there are two vastly different extreme point solutions for supply chains, and reality is going to be somewhere in the middle. And most firms aren't going to have just one or the other. They're going to have a portfolio of different supply chains that can meet the needs and requirements of all their products, because every company will have some functional products and some innovative products. And so they need the supply chains to be able to adapt and be flexible to handle all the different products. Also, functional products can be innovative. So you look at soup, and the can of soup looks pretty traditional, hasn't changed for about 100 years, but they also have other things that come out like soup in a bag, soup for a microwave, different innovative products. So some of those products are more like these smartphones over here, the innovative ones. You don't know what the demand's going to look like. It's a short life cycle. You might not know how long you'll keep it. So some very functional looking products, especially if they're offered under new product promotions, will behave like an innovative product. Over time, the same thing can happen in reverse. Innovative products can become functional. And so why can that happen? Well, let me give you some examples. So let's look in the high-tech world, and this is where it happens a lot. Look at Intel. The market for computer chips have shifted dramatically in the last 20 years. It has shifted from mostly PCs to laptops and notebooks to tablets and smartphones. In fact, in 2014, while about 200 million PCs were sold across the world, 1.8 billion smartphones were sold. So this looks like good news to Intel because they put chips in everything. But the downside is the cost of chips in a smartphone is about 1/5 of that in the PCs. So what that means is the profit margin shrinks dramatically, so you're going to treat it very differently. You're no longer going to fly a chip across the world 6 times to go to different production plants. You need to start being more concerned about the costs, so it becomes more efficient driven. Same thing for memory storage. The prices dropped from about $1.50 per megabyte in 2000 to less than 1/2 penny per megabyte in 2015. That's incredible what the drop is doing. So you no longer have that profit margin, so now instead of being innovative, I have to be more functional. I have to treat that product as a functional product and really get a handle on my costs, and that changes the way you'll set up your supply chain. Totally different industry, pharmaceuticals. When most pharmaceutical drugs are introduced, they're protected by patents. Patents allow exclusivity, but after a certain time, in return for getting awarded this patent, it'll go off patent at a certain time, and at that point, when it moves off that cliff, then generic manufacturers can produce them. So what's the effect there? Well, let's look at Lipitor. Lipitor is the best-selling drug of all time for Pfizer. It was introduced in the mid-1990s, and for about 10-15 years, it was earning about $11 billion a year. It was Pfizer's largest drug sale, largest source of revenue. In 2011, it came off patent. Immediately, even Pfizer started selling it for about 80% of its price. The price dropped so much that they had to now start protecting from generic manufacturers. So at the same time, their profit dropped by over 50%. So what was once a drug which had high margin because it was protected under this patent, had exclusivity, suddenly you have competition, your margins go down, so now I have to treat that very differently. This is a classic example of moving from an innovative product where I always want to meet demand, I don't care about the cost, meet demand, to now where I have to be functional, I have to be very efficient because the margins dropped. So these things can happen all the time. Another case study, and this is a great one, this is about HP and their inkjets and their other printers, and this is from a paper by Olafson, Lee, and Denise. And what they did is they traced how their supply chain has changed over the last 15-20 years. And so if you look at the supply chain for the printers, you can decide that the different design elements you have is where do you manufacture the core products, how do you get the things from where it's located to where it's going to be distributed, if there's any final assembly, where do you do that, where do you fulfill, and what kind of inventory model do you use. And so when the HP inkjet was first introduced in the early 1990s, they were manufactured right where the market was, within the United States and Europe. They used rail or truck, kind of an intermediate speed, to get to their markets. Everything was done on close to market. However, In the late 1990s, they changed things a little bit. They found, moving manufacturing to Singapore, and in this case, wherever it is offshore, in this case it was Singapore initially, and then eventually moved to China, you can really reduce the manufacturing cost, and you can bring in the core components by ocean. However, what they did is they used postponement. And so what they created was the vanilla printer, and they did the customization for each country close to market. So that way, they decoupled the core component, which had very stable demand, and they did the customization much later. They postponed it till it hit the market. And they did all that in the more expensive areas, but still they achieved a lot of benefits by manufacturing from a very low-cost location. Now their inventory stocking now means they configure to order. So they get the raw material, the vanilla printer, and then they customize it close to shore. But this didn't last as long. In the 2000s, they've shifted again, which proves the point that supply chains are never stable and constant. They're constantly changing. So what they did here now, they stayed with the manufacturing, and in fact, they moved from Singapore to China to even lower cost. They found the benefits there were so dramatic that they decided to build the entire supply chain, the finished product supply chain, off-site. And then they move the finished product to the final market and where they fulfill, and they do build to stock. Now, why was that done? Well, there's 5 reasons. 1, the market is much more predictable and inventory rates are much lower now than they were in the early 1900s. There are many fewer SKUs now. The market is much more mature for the printer market, so they have fewer, therefore risk pooling is not as beneficial. The product quality, it's a very mature product, is very stable, minimal rework, so it's not as much of a concern. Printers are smaller. They're about 1/3 the size of what they were when they were first introduced. So shipping the finished product all the way over ocean is much cheaper. And finally, the manufacturing costs offshore are so much lower, they dwarf any improvements or any benefit they had from doing postponement at the close to market in a more expensive environment. So this is a great example. You have the paper attached to this video, so you can read that as well. But what it illustrates is that a company needs a portfolio, the supply chain design portfolio. And you can think of, there are 3 or really more options, but in this case just 3 options that are listed for each type of supply chain function that you need to design. You have a high cost or a very fast option. At the opposite end, you have a lower cost, a slower option, and then you usually have something in the middle, the Goldilocks option, right? Just in the middle. And so for each of these, manufacturing, the way you ship, final assembly, order fulfillment, and inventory stocking, you can see that there's different options. And depending on your situation, what they talk about in the paper is how they decided to select which option which made sense for that product at that time. And so you can use this as kind of a template, and it's just an example for what they did at HP. But it shows the concept that you need to constantly be trading off cost versus service and always looking for innovation in how you design your supply chain.